So this is a continuation of our calculus problems. In this question, we'll be solving the given function. So before we begin, don't forget to like and subscribe. So to differentiate this function, all you need to do is to understand that it's in parts. You have y being equal to 2x plus e to the x ln x. So you have two portions because you have the sum in between the two entities. So you can differentiate 2x separately and e to the x in x. So you can just say, let's call this our first data. So this is data 1. Let's call this one data 2. So let us see to it that we evaluate data 1. So let data 1 be equivalent to some random function, say p, being 2x, and differentiate it. Differentiating p will be p prime being equal to 2. Then you also differentiate data 2, like you did for 1. So for data 2, pick an arbitrary term for your function, say q. Say q is equal to e to the x in x. Then differentiating this, you basically use the product rule. So you say a prime b plus b prime a. So you have to understand that we're going to look for the value of a, b, a prime, and b prime. So let a be equal to e to the x. Then a prime will still be e to the x because e to the x doesn't really change. Then look for b. B will be the other function, which is ln x. Then b prime will be the derivative of ln x is 1 over x times the derivative of that particular x variable, which is a something, which will just be 1. Then substituting this back into our q prime function, we'll get a prime, which is e to the x. Then b is simply just ln x plus b prime, which is 1 over x, times a, which is e to the x. So q prime is equal to e to the x times ln x is e to the x ln x, plus if you multiply this portion there, you have e to the x over x. Now that you have found your q prime, you can take your datas back to your y. So this implies that y prime is equal to p prime plus q prime. So y prime is equal to p prime, which is 2, plus q prime, which is e to the x ln x plus e to the x over x. So this is basically our final answer. So you can either simplify or express the entire thing as a single fraction, or you can literally just end here. Alright, thanks for watching. See you in the next problem.